What makes a raisin a testament to smart agriculture? What transforms one of America's most classic industries into an almost entirely hands-off industrial chain? How does it feel to not need to pick grapes or dry them, yet still obtain a perfect raisin? In California, the raisin capital of the United States, things are operating in a way you wouldn't imagine. Not a factory, but a field operating like a logical assembly line. Not fruit, but a high-tech product, monitored down to the pixel. In this journey, we will explore: why did the state of California reject the traditional sun-drying method and choose to dry right on the vine? What kinds of machinery, sensors, and AI are being introduced to each bunch of grapes? And is this one of the most highly automated agricultural sectors in the United States? Stay until the end, because the story you're about to see might completely change your definition of dried fruit in the modern world. Have you ever seen people drying grapes on the ground, under the scorching sun for weeks? Or bringing them into large-capacity drying ovens, rotating continuously to create raisins for tons of export orders? But what if the entire drying process happened right on the grapevines themselves, without anyone touching them? In California, where over 95% of all U.S. raisins are produced, they are implementing a method that sounds counterintuitive: dry on vine, also known as DOV. But how do grapes dry while still hanging on the trellis? The answer lies in a small but meticulously calculated operation: cutting off the main vein that supplies water to the grape cane, a technique called cane cutting. When the water flow stops, the grapes begin to gradually lose moisture, but they don't fall off, don't rot, and don't need to be picked. Everything else, nature takes care of. And within 2 to 4 weeks, the grapes transform into raisins on their own, right on the trellis wires, in a state where growers only need to observe from a distance. Sounds simple? But this is the starting point of an entire logical operation, where the timing of cane cutting must be decided by temperature sensors, humidity sensors, and weather forecasts. Why did the US choose this method instead of tray drying or machine drying? Because DOV offers significant advantages. Up to 40% reduction in labor costs because there's no need for people to pick, dry, or turn them. Raisins have a more uniform sugar content because they lose moisture slowly, without being heat-shocked. Minimized risk of mold and insects, which are very difficult to control in ground drying. And most importantly, this method creates the foundation for complete mechanization, something that traditional methods cannot achieve. No need for workers to watch the sun or turn trays, just a properly timed shaking machine and a monitoring system with the right indicators, and the entire field will dry evenly, as if by programmed command. But to do nothing and still achieve results requires an extremely precise monitoring system. This is no longer traditional agriculture. This is a precision agriculture model, where every operation, from the timing of cane cutting to monitoring ambient humidity, is calculated using data. Even the trellis wires supporting the grape canes must be designed to be durable and well ventilated, to keep the grapes suspended, drying gradually without getting waterlogged or developing mold. And for everything to run so smoothly, the farms use multiple layers of integrated technology: on-site weather sensors, forecasting ideal drying conditions, satellite and drone imagery, detecting which areas have reached the drying threshold and which need more time. And of course, humidity, light, and wind data, analyzed to determine the optimal time to shake the vines, dry enough, but not too dry to shatter. Are you impressed by this no-picking method? A model where nature does the work, but humans monitor every hour, every millimeter of dryness. If you think the strangest part is just not touching the grapes, then keep going, because the next scene is when an entire field begins, harvesting without pickers. If in many places, each raisin is associated with the hands of a farmer, in California, They are associated with sensors, shakers, and packaging robots. Imagine a vast field of raisins without pickers, without drying trays, yet yielding thousands of tons of raisins in just a few days. So who is doing that work? In the dry-on-vine method, when the grapes reach the desired dryness, around 13 to 16% moisture, they are not picked by hand. Instead, a specialized vibrating machine, mechanical shaker, travels along the rows of trellised vines, stopping at precisely programmed points. Hydraulic clamps gently grip the trunk of the vine. A short vibration, not too strong, not too weak, just enough to make the properly dried raisins fall. They fall onto a catching tarp below, or a vibrating trough that leads directly into containers. Have you ever thought that a vibration could completely replace an entire team of grape pickers? But the remarkable thing isn't the shaking force, it's the timing of the shaking. But who decides? The answer: data and sensors. On modern farms in California, farmers no longer walk through the fields to check the dryness of the grapes as they used to. Instead, they check data dashboards to create priority harvest maps so that machines move to the correct location, shake the correct vines, at the correct time. Air humidity has decreased steadily for 3 consecutive days. West wind is blowing steadily, with no rain forecast. Drone images show that 82% of the trellises have grapes that have reached the standard color. The vine shaking command is activated. Harvesting can take place without the harvester, even seeing the grapevines. Is this still farming, or is it coordinating production like an assembly line? The grapes that fall to the ground don't do so randomly, but they fall according to programming. Immediately after falling, the raisins will not lie on the ground, a major violation of USDA standards. Instead, high-powered vacuum devices, mounted on all-wheel drive tractors, will suck the raisins directly from the tarps, simultaneously moving and collecting them into temperature-controlled containers. Some farms use vibrating troughs with weight sensors. If the collected raisin volume exceeds the allowed limit, the system will temporarily stop to prevent the raisins from being crushed. No contact with the ground, no hand contact, no outdoor storage for more than 1 hour from the time they fall. This is how they ensure the journey from the vine to the factory takes 2 to 4 hours, almost uninterrupted. Think that's it? Not at all. This is when they enter the factory to get ready for a new journey. Once inside the factory, each raisin goes through a conveyor belt to separate large objects, stems and broken twigs. After that, the raisins are washed with gentle, pressurized cold water, ensuring each one is cleaned without softening the skin. No soaking, no hand scrubbing, just enough to remove what the human eye can't see, but food standards don't allow to exist. Even though DOV helps raisins dry naturally on the vine, each bunch might dry with a slightly different moisture content, a 2% variation, and the washing process can cause the surface of the raisins to absorb a little moisture. Therefore, the raisins will be put into a final drying oven, also known as final dehydration, at a lower temperature than traditional drying, around 140 to 149 degrees Fahrenheit, 60 to 65 degrees Celsius, for 2 to 4 hours. The goal of this step is to reduce the moisture content below 16%, according to USDA Grade A standards. It also helps to fix the fruit's structure, increase shine, and extend shelf life. After being clean and uniformly dry, the raisins enter the final quality check, a high-speed camera system. RGB cameras check the color. If they're too dark, they'll be rejected. Near-infrared (NIR) cameras assess the dryness and residual sugar content. Any substandard raisins will be blown off the conveyor belt by jets of compressed air. No workers with lamps inspecting. No one with nets catching. It's all sensors. It's all images. It's all learned from millions of raisin samples trained from the previous harvest. After sorting, the standard grade raisins are fed into an automated packaging system. Vacuum sealing at a pressure of -0.08 megapascals. Cold packing at 50 degrees Fahrenheit, 10 degrees Celsius, to preserve pliability. Printing QR codes containing vineyard code, harvest date, machine shift, inspection camera code. Some major brands in the US, like Sunmade or National Raisin, are implementing blockchain traceability, allowing consumers to know exactly where each package of raisins comes from, within 3 seconds of scanning the code. Everything you see, from the shakers to the cameras, has one thing in common. They replace human senses, reflexes, and even judgment. No one looks at the color of the raisins. There are sensors for that. No one monitors the dryness. There's machine learning AI for that. No one picks by hand because the air jets are accurate down to each individual raisin. The question is this still harvesting, or is it a biological assembly process where fruit isn't picked, but processed? We still call this growing grapes, making raisins. But in reality, if you look closely at the entire process from the vine to the supermarket, you'll see something different. This isn't an agricultural chain. It's a distributed data management system, with biology as the input and traceability as the output. The core difference doesn't lie in each individual piece of equipment. It's in how everything is linked into a seamless system. Data from the vineyard connects directly to the operating schedule of the shakers. Moisture content information immediately sends a command to the packaging department. Dozens of satellite farms, all synchronized on a central data platform. Farming is no longer grow it yourself, harvest it yourself, but participating in a multi-point logical operating chain. In many places, the quality of raisins depends on whether it rained that day, who did the turning, and who did the drying. But here, everything must be the same down to each parameter. Moisture content, less than 16%. Brix level reaches 55 to 70. Uniform raisin color at scale 3 to 4. Foreign material less than 0.1%. All of this is clearly stated in the USDA Raisin Grade A standards, which any factory in California must adhere to like strict law. That uniformity is the reason why American raisins can enter the most demanding markets like Japan, Germany, and the UAE. Because sometimes, what customers buy isn't fruit, but consistency down to the gram. When everything is digitized, agriculture becomes easily scalable. You can copy a plant variety, but it's not easy to copy how data operates. You can buy machinery, but it's not easy to design a production chain with step-by-step logical coherence. That's why, while other countries are still discussing product quality, the US is already discussing optimizing domestic logistics to reduce cooling costs. Forecasting demand based on consumer behavior through retail AI. Balancing raisin and wine grape production according to market signals. Perhaps, raisins aren't just a product, they're a platform where the US uses technology, standardization, and data to dominate the market. From the grower to the shaker, from AI sorting to traceability data, from the field to the Costco shelf, each seemingly separate stage operates according to a common, precise logic, with no randomness, no exceptions. When everything operates like a line of code, is there still room for the farmer's intuition? The answer is yes, but it's no longer in the operation itself. Intuition, in the age of high-tech agriculture, is no longer about going out to the field in the morning, looking at the clouds, and deciding when to plant. It's also no longer about turning grapes by hand, tasting each one, or adjusting based on instinct. Intuition, if it still exists, has moved to the strategic level. It lies in deciding which varieties to choose for which soil types, programming the farming system to take advantage of each year's climate, and in designing an entire data chain, and then letting the machines execute what you envision. Humans are still playing the music, but now they write the music with source code. Intuition hasn't died. It's just been abstracted into the ability to create systems. Instead of doing, the modern farmer creates how things are done. And that, perhaps, requires even more creativity and emotion than any era before. A raisin. It sounds simple. But when you place it in the middle of a system of shakers, humidity sensors, AI cameras, and a blockchain traceability chain, it's no longer just agricultural produce. It becomes a unit of information, an industrial standard, a link in a pickerless production ecosystem. We used to think agriculture is hands touching the soil, but the raisin industry in the US is showing something completely opposite. When no one touches it anymore, that's when precision, speed, and standardization truly begin. Do you choose the stability and precision of technology, or do you still long for a day to taste grapes, picked by hand under the real sun? Leave your thoughts below the video so we can discuss. And don't forget to subscribe if you want to continue exploring familiar agricultural products through the lens of paradox, data, and unexpected transformations. See you in the next video.